For performance task number 1, calculate the line current required for a 30 kW 3-phase motor having a power factor of 0.85 lagging. If it is connected to a balanced source with a line voltage of 440 volts. Our given is real power P equals 30 kilowatts or 30,000 watts. Power factor with the formula of cos theta P over S equals to 0.85 lagging. Line voltage VL equals to 440 volts. And our formula, apparent power S equals square root of 3 VL times IL. We will transform the formula to get the IL. IL equals S over square root of 3 VL. To get the value of S, we know the formula for power factor. Power factor equals P over S will be transformed to S equals P over PF. Our S is equals to 30,000 watts over 0.85 is now equal to 35,294.1177 watts. Now we will get the line current IL with the formula of S over square root of 3 VL is equals to 35,294.1177 watts over square root of 3 times 440 volts. Our line current is now equal to 46.3115 amperes. In number 2, assume that the two balanced loads in figure 3 above are supplied by an 840 volt RMS 60 Hz line. Load 1 is Y connected with 30 plus J40 ohms per phase, while load 2 is a balanced 3-phase motor drawing 48 kilowatts at a power factor of 0.8 lagging. Assuming the ABC sequence, calculate A. The complex power absorbed by the combined load, B. The kVAR rating of each of the three capacitors delta connected in parallel with the load to raise the power factor to unity, and C. The current drawn from the supply at unity power factor condition. We have a given line voltage of 840 volts, real power for load 2 with 48 kilowatts, and the impedance of 30 plus J40 ohms. The complex power S1, we have the formula VL squared over conjugate of impedance Z is equals to 840 squared over 30 minus J40 ohms. Now our complex power S1 is equals to 8.4672 plus J 11.2896 kilovolt ampere. For our complex power S2, we need to get the reactive power Q2. Q2 equals P sub 2 tan theta sub 2 is equals to 48 kilowatts tan cos raised to negative 1 0.8. 48,000 watts tan 36.8699 is equal to 36 kVAR. Now for our complex power S2, we have the formula P sub 2 plus the reactive power Q2. 48 kilowatts plus J36 kVAR is now equal to our complex power S2 48 plus J36 kilovolt ampere. For the total power ST, we have to add them up. S1 plus S2 is equals to 8.4672 plus J11.2896 plus 48 plus J36 kVA is equals to total complex power 56.4672 plus J47.2896 kilovolt ampere. Now we have the total complex power of 56.4672 plus J47.2896 kilovolt ampere. We will convert it to its polar form. which is 73.6536 bar angle 39.9452 degrees kilovolt ampere. We can also get its real power from the given total complex power of 56.4672 kilowatts and its reactive power of 47.2896 kVAR. We will treat the angle of 39.9452 degrees as the old angle, and the new angle is equals to cos raised to negative 1 times 1. We have the condition having the power factor of unity, which is equals to 1. Reactive power for the capacitance QC equals P times the quantity tan theta old minus tan theta new. 56.4672 times 10 raised to 3 times tan 39.9452 minus tan 0 degrees. It is equals to QC equals 47.2896 kVAR. For our capacitor kVAR rating, we have to divide it by 3 to get each capacitor rating. QC equals QC over 3 equals 47.2896 times 10 raised to 3 over 3. Now, QC is equals to 15.7632 kVAR. To get the line current, IL equals S over square root of 3 VL. Here we substitute the power factor of 1 in the reactive part, which is tan cos raised to negative 1 times 1. Now our S equals P plus JQ is equals to 56.4672 plus J0. Our S, or the complex power, is equals to 56.4672 kilovolt ampere. We will substitute it to our formula for getting the line current. S over square root of 3 times VL. 56.4672 times 10 raised to 3 over square root of 3 times 840. We will get the line current of 38.8111 ampere.